Okay, from the last video, we just found out that our sample does meet these three conditions, so we can proceed with constructing what we call a z-interval, a confidence interval for the population proportion rho. Now, how do we do that? Well, just like I said, I keep repeating this, but just like with last target, it's basically your point estimate plus or minus your margin of error, where your margin of error consists of a critical value times your standard error. Now, we call this a one proportion z-interval, okay? When we did means, it was called a one, I can't remember what it's called, a one sample t-interval, there you go, is what it was called. Well, when the conditions are met like they were previously, we were ready to find that level C confidence interval for the population proportion rho. So how do we do that? Well, it's this formula right here. Okay? We're going to take our point estimate p hat plus or minus our critical value, which we get from a normal distribution, times our standard error, and basically we just calculate two limits. We take p hat plus the margin of error, and remember, ladies and gentlemen, this whole thing right here, and I'm going to circle and erase it, this whole thing right here, ladies and gentlemen, that is your margin of error, okay? All right, that's the distance from your sample proportion to your upper confidence limit and to your lower confidence limit, all right? So, ladies and gents, and when we do this, we always want to make sure we round that confidence interval limit to 3 significant digits when we use proportions. Now here's just again some notation you can use, and there again at the bottom is your margin of error. If you get stuck with the notation or so forth, just refer back to this slide. Now remember that we usually like to write there's different ways to write a confidence interval, but we like to write it like this, where we have our lower limit, which is found by taking p hat minus your margin of error. We're estimating the population proportion rho, so that's not p hat. You don't ever put p hat there. We're not estimating p hat. We know what p hat is from our sample. We're estimating the population proportion, and then we get our upper confidence limit by taking p hat, our point estimate, plus our margin of error. Now there's other ways to write it here and here, but I really like this first way of writing it as an interval, like you learned in algebra. Okay, so let's go ahead and set up, ladies and gentlemen, and construct an actual 95% confidence interval for the true proportion of adults who know what Twitter is. All right, so if we do this, now I am going to tell you this, you don't want to round values during your calculations. They could really distort your results. The rounding errors get pretty huge. So I would try to use the memory function on your calculator when you do this. And again, try not to round during the calculations, only round your final answer. Even though I will, when I write stuff down, and you can too, when I write the work down, I may truncate it or round it, but on my calculator, I'm still using the entire value. So, if we're going to do this, then a couple things we need to know. First of all, we know p hat was 0.85. 85% of adults said they knew what Twitter was from the sample. Our sample size was 1,007. Now, since it's a 95% level of confidence, our critical z value is going to be 1.96. How do I know that? Because for a 95% level of confidence, your z value is always going to be 1.96. That critical z score is going to be 1.96. Now again, you can go back and go to the normal distribution if you look on, I think it was slide number 1 or 2, and you can figure out how to, ladies and gentlemen, come up with that value. There's also a table there on a previous slide, but that's not going to change. For all 95% level of confidence, regardless of the type of problem we're doing, it's going to be 1.96. So now we do the calculation. So again, remember, we're going to take p hat plus or minus our critical z value times our standard error, which is p hat times 1 minus p hat all over n, and we're gonna take the square root of that. So, I've already done the calculations ahead of time, I'm just gonna box that off so we know. But p hat was 0.85 plus or minus 1.96 times 0.85 times 1 minus 0.85, and you can actually write that as 0.15 if you want to, all over n. So if we start doing the calculations, this is 0.85 plus or minus 1.96, and from the calculator, you get this to be 0.011252, and it goes on and on, okay? Don't round that to 0.011 or else you're gonna get some rounding error. So if we keep going, excuse me, 0.85, if I take 1.96 times this amount, then I get 0.02205446. And then if I take my 0.85 minus this, and I round to 3 significant digits, I get 0.828. Is less than, and we're going to put rho here, because that's what we're estimating, the population parameter. And then if I take my p hat, which is 0.85 plus this value, rounded to 3 significant digits, I get 0.872. So right there is my confidence interval for the proportion of adults, all adults who know what Twitter is. If you want to look, it's somewhere between 82.8% and 87.2% with a 95% degree of confidence.